So in this little video, we're going to solve things which have exact solutions. Sometimes it'll say that in the question. The other way you'll know is if they put one of these kind of solve questions into the middle of a non-calculator paper, get suspicious that you probably need to give an exact solution because you don't have a calculator to reverse the process. It's going to be one of the ones that you know. So that's the big clue. Often this will come up in a non-calculator. Most of your calculators, if you do an inverse sign of this, will actually give out the right answer if you're in the correct mode. It will, even in radians, it'll give it out in terms of pies rather than as a decimal for most of you. So this is something that really was more likely to come up in a non-calculator paper where you've got an exact solution answer. So we're going to look at two examples and two your turns where you can have a go, and then I'll run through it. So looking at this one here, we've got solve sine of x equals root 3 over 2. First thing we want to do is x equals sine to the minus 1, and it's positive, so we don't need to worry about it, root 3 over 2. But this time, instead of using a calculator to do that, we're going to bring out our handy table. Sine of x is root 3 over 2, and here we're working in radians. So looking at sine of x being root 3 on 2, looking at our radians column, it gives us pi over 3. So x equals pi over 3. Now we're going to split. We're going to look at our two methods. Our graph method tells us if we're at root 3 over 2, that's a positive number. Don't worry too much about what it is. So one of our values is there, and the other one is here. This bit of graph here matches this one. So we're going, same as going forward from 0 is the same as coming back from the middle of our graph, which is pi. So our other value is going to be at pi, take away pi over 3. Now, if we're working in exact values, this is more likely to be in a non-calculator paper. So we've got to think what to do here. Well, we're working in thirds. So whole pi is the same as 3 pi over 3. Take away 1 pi over 3. So what do we get left with? Well, we get left with 2 pi over 3. There's our answer in radians. 2 pi over 3 is our other value where this happens. If we're using a cast diagram, in this case, because it's positive, our relative acute angle is just pi on 3. Where are we positive with sine? Well, we're positive up here and we're positive here. This is pi because we're working in radians. This section is pi take away the relative acute angle. So it gives us that same calculation. So one of them is pi on 3. The other option is 2 pi on 3. So have a go. See how you get on. Try and solve tan of x equals root 3. Give you a little pause in the video. You can have a go at solving that. So I left you with tan of x equals root 3. First thing we want to do is x equals tan to the minus 1 of root 3. Because we're working with exact values in radians, we're looking up our table. In our table, tan of x equals root 3 when we're working with pi on 3 radians. So that is pi over 3. Doing that, we're now thinking graph or cast. I don't mind which one you're doing. Graph-wise, we're working up here, going like that, and up to there. Remembering that we're at pi on 2 there. Pi is in the middle here. 3 pi on 2 and 2 pi along here. Got a positive value. So that means it must be about here. That's root 3. So our first value happens here at pi on 3 along. So that's coming along by pi on 3. Our second value is along here. So that's like exactly the same bit of graph there as we had there. So we're doing pi plus pi over 3 here. Now, based on what we did last time, this one here is 3 pi's over 3. We're adding another pi over 3. So altogether, we've got 4 pi's over 3. So that's our exact answer is 4 pi over 3, or 4/3 of pi. Can do exactly the same with cast. So in cast, where is tan positive? Well, tan is positive when they're all positive, and it's positive when t is positive. That is pi, because we're working in radians, which we know from that bit of the question. So this one is our pi over 3 angle up here. Down here, we're working with this angle over here. So it is pi plus pi over 3. And that is exactly the same calculation we had there. So two slightly different methods as ever, but exactly the same answer. But the key thing here is that we're doing this step here using our table rather than using our calculator.